You know how the apps on your phone just seem to magically update themselves, or how huge websites can change from one day to the next without completely falling apart? Well, today, we're going to pull back the curtain on that fast paced, sometimes chaotic world of modern software development to see exactly how it's all done. But first, let's talk about the dark side. We've all heard the horror stories, right? A huge project goes way over budget. A big launch day turns into a total meltdown. Or a new feature just flat out doesn't work. It happens way more often than you'd think. So what's the real reason so many of these digital projects just fail? Now, you might think it all comes down to a bunch of brilliant programmers writing perfect, flawless code. And yeah, that's obviously important. But believe it or not, that's rarely the root cause when things go completely off the rails. The real problem is usually hiding in plain sight. That's right, the process. It's all about how the software gets built, tested, and actually delivered to you. The hidden machinery running behind the scenes. That's what separates a massive success from a total disaster. And to really get why the new way works, we first have to understand why the old way was so broken. So let's take a look at the old way of making software. I want you to picture a gigantic traffic jam. Every single team, the developers, the testers, the support folks, they're all stuck in their own separate lanes, barely moving, and they can't really talk to each other. For decades, this was pretty much how it worked. This method even has a name, the waterfall model. And you can see why. The development team would finish writing their code and basically just toss it over the wall to the release team. Then, the release team would test it and throw it over another wall to the support team. Every single handoff created delays, huge misunderstandings, and just a massive potential for things to go wrong. To see just how bad this could get, let me tell you a quick story. This is Alice. She's a developer, and she finds a really nasty bug. A tax return is being reported as filed when it actually isn't being sent at all. Yikes. She jumps on it and fixes it right away. A crucial save. Okay, now here comes Bob. He's working on something totally different, just tweaking the user interface. But to do his work, he needs a copy of that same tax module. And here's the problem. He grabs his copy before Alice had a chance to save her fix. He has absolutely no idea he's working with a broken piece of code. And this is where the disaster happens. When Bob saves his changes to the user interface, the system just takes his version of that tax module and completely, silently, overwrites Alice's critical fix. There are no warnings, no red flags. Her fix is just gone. The outcome is just catastrophic. The product goes live, bug and all. Users start getting fined by the tax service. The company gets sued for negligence, and all trust is completely lost. The business fails. And this all happened not because of bad coders, but because of a deeply flawed process. Clearly, there had to be a better way. And thankfully there was. A whole new philosophy started to emerge called DevOps. It's a mashup of development and operations. And this wasn't just some new tool. It was a total revolution in how teams were supposed to work together. This slide really nails the difference. On the left, you've got the before picture, those separate teams working in their own silos with walls between them. But on the right, you see the after. It's one integrated team, and everybody shares the responsibility. The walls have finally come down. This whole philosophy is really built on three key ideas. First, shared responsibility. No more, that's not my job. Everyone owns the entire process. That's a huge cultural shift. Second, automation. If a machine can do a repetitive, error-prone task, let it. And third, measurement. You use data, not just guesswork, to figure out what's working and what isn't. And that second principle, automation, that is the engine that makes this entire thing go. So let's dig into the actual tools and processes that turn this DevOps philosophy into a day-to-day reality. So job number one is to solve that whole Alice and Bob problem for good. And that's done with something called code management systems. You can think of it like a super smart shared folder that actually understands programming. It is the absolute backbone of all modern software development. With a system like this, that whole disaster we talked about, it just couldn't happen. Every single change is tracked. Bob would have worked on a safe, separate copy or branch of the code. And when he went to save his work, the system would immediately see that his version conflicted with Alice's recent fix, and it would have alerted both of them. It would force them to carefully combine or merge their work. No more silent overwrites. Problem solved.
This really is the central mantra of DevOps. By automating the whole process of building, testing, and releasing the software, you make it way faster, way more reliable, and just completely repeatable. And this automation is handled by something called a pipeline.
So let's walk through how this pipeline works. It's called the CI/CD pipeline. It all starts with continuous integration, or CI. That means every single time a developer saves a change, the entire system is automatically built from scratch and tested for errors. If it passes, it moves to the next step, continuous delivery. This is where that tested code is automatically packaged up and made ready for customers. And the final optional step is continuous deployment, where that new version is automatically pushed out to users. It's just a constant automated flow of improvements, going from the developer's keyboard right to your screen.
And this whole automated process is so essential because of a fundamental truth about software. It's never really finished. It's honestly more like a living thing that needs to constantly grow and evolve. I mean, think about it. New operating systems come out, new security threats pop up, and we, the users, are always asking for new features. A piece of software that just stands still becomes useless really, really fast. So change isn't some special event. It's the normal state of being. And this chart really drives that point home. When we hear the word maintenance for software, we probably think it's all about fixing bugs. But just look at this data. A massive 65% of all that effort goes into adding new functionality, into making the product better and more valuable for all of us. But with all this constant change, there's a risk. The code itself can get messy and fragile over time. To fight against this decay, developers are constantly refactoring the code. The best way to think about it is like combing out tangles from your hair. They're always making these small improvements to the internal structure just to keep it clean, understandable, and easy to change down the road.
So, what's the big payoff? What's the end result of this massive shift in both culture and technology? Well, it all boils down to delivering better software to you, the user, way more quickly and with a whole lot less risk.
And the data, well, it speaks for itself. As you can see here, teams that use these modern practices see their deployment frequency just skyrocket. We're talking about releasing new features daily, sometimes even hourly. At the same time, because all the changes are small and automatically tested, the number of failed deployments just plummets. And if something does manage to go wrong, their time to recover is measured in minutes, not days. So we've gone from the total chaos of that waterfall traffic jam to the smooth, continuous flow of the DevOps pipeline. The way software gets made has been completely transformed, which leaves us with a final thought to chew on. If the apps and the websites we rely on every single day are in this constant state of evolution, what does it even mean for a piece of software to be finished? And how does this world of perpetual updates change what we expect from our digital tools?